in problem number 2, we have another related rates problem, and this one's kind of a creative situation where we have a guy looking at stuff that's falling out of a window, and he's looking at his TV, and the guy is standing 10 feet away from the building. The window that the TV is being dropped out of is 20 feet high, but this problem asks us to evaluate this once the TV is halfway down. So the TV is 10 feet up from his eye level. And therefore, if you drew a line from his eyes to the TV, we made a right triangle right there. And that's what this problem is getting at. So his line of sight makes an angle theta relative to him looking at the apartment entrance. And we want to know how fast is this angle decreasing when the TV is halfway down, assuming it's falling at a rate of 30 feet per second. So I'll redraw the triangle out here with the terms on it that we need. So we are interested in theta. That's what we're interested in the problem, how fast the angle is decreasing. So that should tell you immediately that d theta dt, we don't know, and in fact that's what we're looking for. So we need to find an equation to take the derivative of with respect to time, and it needs to involve theta because that's what we want to find. So we also need to draw whatever else is on this triangle. Well, he's 10 feet away from the building, but that's not changing as the TV is falling, right? The distance horizontally from him to the TV or him to the building is 10 feet. That's always the same. So therefore, I can write that as a number and not a variable. Remember, when you're setting up your related rates problems, anything that's changing has to be a variable. So even though I could have figured out what this angle was right at this moment, I'm not interested in that right now. So the other thing that's important here is this vertical distance, which I'll just call x. Again, at the moment we know it's 10, but that's not what I need for setting up my equation. X is definitely changing because as the TV falls, x is getting smaller. So therefore, x is a variable, and there in this picture now we have all the things that are important to me. I need to know theta, and I need to find an equation that relates theta to the other things happening in the problem. So now I need an equation that relates all three of those quantities, and the easiest one to do here would be tangent. So tangent theta is equal to x over 10. The way that I drew this triangle, because tangent is opposite over adjacent. This is a perfectly valid equation, and that's exactly what we want to now take the derivative of dt, because we'll get the things that we need to come out of this. So the derivative of tangent is secant squared theta times d theta dt, because we're taking the derivative with respect to t. The derivative of x over 10 is 1/10, but we also have to multiply by dx dt. So now you can see we have three variables. We have theta, or we have secant squared theta, we have d theta dt, and we have dx dt. Now d theta dt is what we want in this problem. So therefore, we need to know the other two things. So first, let me rewrite this so that it's solved for d theta dt. So this is 1/10 dx dt. And instead of dividing over by secant squared, just remember that secant is the reciprocal of cosine. So actually I can just write this as cosine squared multiplying by cosine squared. So as you can see, I need dx dt, I need cosine squared of theta to answer this problem. So let's see what we're given. One thing that we didn't incorporate on our drawing but was given to us in the problem, it said that the TV is falling at a rate of 30 feet per second at the moment. And that will help us get our dx dt, because dx dt is how fast is this distance changing. Well, if the TV is falling 30 feet per second down, that means this distance from the TV to the guy, vertical distance, that's getting smaller at a rate of 30 feet per second. So therefore, our dx dt is negative 30, because x is getting smaller at the rate that the TV is falling. So there's our dx dt. And lastly, we just need to figure out cosine squared of theta. So now is when we actually do think of, okay, what is the angle at the moment that we're talking about? Theta is part of this triangle, and the opposite and adjacent angles, or opposite and adjacent sides, are exactly equal at this moment. That means that this is a 45, 45, 90 triangle because the legs are equal, right? If x is equal to 10 at the instant that we're talking about, then this is a 45, 45, 90 triangle, which means theta is 45 degrees, or pi over 4. So if theta is pi over 4, and we're doing cosine of that, remember that cosine pi over 4 is square root of 2 over 2. But if we square that, which is what we're doing here in this equation, squaring this would just give you 2 over 4, which is a half. So therefore, we can plug in all of our numbers now to answer this problem. So d theta dt is equal to 1/10 times the x dt, which we said was negative 30, times cosine squared of theta, which cosine is root 2 over 2, so cosine squared is 1/2. So we can simplify some things here. Negative 30 divided by 10 would be negative 3, and then times 1/2, so we get negative 3/2 when we multiply all those together. Keep in mind, what unit is that in? Well, the dx dt, this was in feet per second, so this is obviously in something per second. It's the rate of change of an angle, so you would say that's in radians per second. And that's our rate of change. Now, one thing you gotta be careful about is that what we just found here, this is the rate of change of theta. So theta is changing at negative 3/2 radians per second. If the problem, though, asks you specifically how fast is it decreasing, well, it's decreasing then at 3/2 radians per second. So remember, the negative being on the value tells you that it's decreasing, but if the question asks you how fast is it decreasing, you can't say then negative. It's decreasing at just a number. So in this case, since the question did say how fast is the angle decreasing, it's decreasing at 3/2 radians per second.
The Teaching Center, UF's Learning Resource Center.